MedCram.
Okay, so welcome to another MedCram lecture. We're going to talk about what may be considered a dry subject, but I think it's actually very important. It's the topic of sensitivity and specificity in relation to statistics. Now, sometimes we see this appear on tests and we got to know what sensitivity and specificity means. I think it's also very helpful in interpreting some of the data that we see in medical journals. And it's actually very helpful in our everyday life in terms of understanding the tests that we're ordering on patients. So I think it deserves a little bit of an introduction and an analysis and how to actually do the questions that you need to do for tests. So imagine, if you will, with me, that you've got a nice car and you want to protect your car, so you install a car alarm. Okay, and it's got a little blinking light there. And you've got a knob in that car that allows you to change the sensitivity on that car alarm. Well, you've got a couple of choices. You can either have the sensitivity high. And what does that mean? That means that, well, if a thief tries to break in, the car alarm is probably going to go off. But it also means that since you're parked on a busy street, if a motorcycle goes by, that could also set it off. So if you have a thief and the car alarm went off, then that would be a true positive result. You would hear that car alarm go off, and sure enough, there's a thief trying to break into your car. That would be a true positive. So the disease here is your car being broken into or is it not being broken into? And the test is the car alarm going off or is the car alarm not going off? And you can actually break this up into a square. And have the four possibilities. So you could, in terms of our disease, you could have a positive disease or negative disease, and in terms of a test, you can either have the alarm going off or the alarm not going off. So in this box here, this would be if there was a thief trying to steal your car and the car alarm was going off. That would be a true positive. Okay? If there wasn't a thief trying to steal your car, but your car alarm went off, that would be a false positive. That would be like a motorcycle going by or somebody touching the car as it went by, and the car alarm goes off, you go out there, the alarm's going off, but no one's tried to break in. And obviously that's not an optimal result. You don't want to have false positives because every single time the alarm goes off, you've got to go out there, you've got to check the car, you got to make sure no one's getting into it. Also, the more times this car alarm goes off, the less likely you are of taking it seriously. So not good. The other possibility is, which is also not a good possibility, is that your car is being broken into, but the alarm doesn't go off. That would be a false negative. That's probably the worst result that you could have. You go out to your parking lot, the car's gone. Okay? The alarm never went off, it didn't disengage the engine. That's a problem. And then finally, the thing that happens, all the time is a true negative. Car alarm is not going off, and your car is not being broken into. So that's a good result. So we like true positives, we like true negatives. We want to minimize these as much as possible. And you can see how that would happen depending on how you set the sensitivity of your car alarm. If you set the sensitivity of the car alarm up very high, what you would see is you would start to have a lot of these false positives, but the chances of having false negatives would go down. Okay? Conversely, if you set the sensitivity of your car alarm very low, you probably wouldn't be getting motorcycles setting off the car alarm. But on the other hand, it might be easier for a thief to break into your car and to steal it without the car alarm going off. So the point here is I want to show you that there's a trade-off in terms of where you set the sensitivity for a test. It's very important because depending on where you set the sensitivity for a test, you're either going to get more false positives or false negatives. And depending on what you're testing for and what kind of situation you're in, you may want to set the sensitivity of that alarm to different areas. For instance, if you're living in a very high crime area where cars are getting stolen every day and there's not a lot of motorcycles, sure, set that sensitivity up pretty high. If on the other hand you're parking your car in an area where there's not a lot of thieves and there's really been no reported thieves, but there's a lot of motorcycles going by, you may want to set that sensitivity low. So it just sort of depends on where you're living. And the same thing applies to medicine. Now we're going to talk a little bit about these false positive, true positives, false negatives in this box in a little bit, but I wanted to introduce to you the concept of what sensitivity is and what specificity is. Sensitivity, mathematically speaking, okay, is the true positives divided by the true positives plus the false negatives. And you can see here that sensitivity is the true positives divided by the true positives plus the false negatives. And so the sensitivity, as you can see mathematically, would be very high if the false negative rate was very low. In fact, if something is very sensitive and it's negative, you can practically rule out that disease. Okay? On the flip side, specificity, which takes this column, specificity is the true negative rate down here divided by the true negative plus the false positive. And clearly you can see there that if the specificity is very high, this false positive has to be very low. And so if something is very specific and it's positive, the chances of it being falsely positive are extremely low. We'll get into that more. Another way they'll sometimes test you is they'll look at all of the different populations of things. Okay, so this is what we're dealing with. If we can go back to the car example. Here is a population of all the things that could falsely set off an alarm. And here is the population of things that could truly set off alarms. So this is what thieves could do. Okay, and so what we're trying to do is we're trying to devise a test that would separate these things out. So what I mean to say here is that this would be the disease negative state. Okay, so this is the disease here is your car being stolen, and here this is all the stuff that could set off a car alarm, but it's not really your car being stolen. So this would be like motorcycles, boom boxes, things of that nature. And this is all of the things that thieves could do to steal your car. So this would be the disease positive state. The problem here is that there's some overlap. And so no matter where you set your threshold for your sensitivity, you're going to have a problem in that you're going to be including one or the other. So there's a couple of areas here where you could set the sensitivity. You could set the sensitivity right here at point A. You could set the sensitivity here at point B, or you could set the sensitivity here at point C, or any of these points. And now I want you to notice here what's going on. So if we were to set it here, then everything to the right would be positive, and everything to the left would be negative. Everything to the right of B would be positive, to the left would be negative. Everything to the right of C would be positive, and to the left of C would be negative. So the question is, and this is the question that you'll sometimes get on tests, is which of the following points represents the most sensitive test, and which of the following points represents the most specific test? So specificity is the opposite of sensitivity in this case. So of course, if you are anything that is on the right side of a test is going to be a positive test. Anything that is on the left side of this point is going to be a negative test. Depending on which population they belong to will tell you whether it's a true or a false, negative, or positive. Let's take, for example, this point here at C. Okay, so here at C, if we were to set the alarm at C in terms of specificity and sensitivity, then all of this area right here would be a positive. Now, because it belongs to the actual disease, it would be a true positive. But all of this back here would be a negative. Now, some of these would be false negatives because they still belong to the disease. But then some of these would be true negatives because they don't belong to the disease. And so what you notice here is that if something is positive, it is definitely part of the disease, but you're missing out on a lot of falsely negative. But notice here that we've moved this C all the way out here so that there is no more false positives. If you have a very low false positive rate, that means you're very specific. Okay? Just for review, remember that the sensitivity is the true positive rate divided by the true positive rate plus the false negative rate. And the specificity is the true negative rate divided by the true negative rate plus the false positive rate. So because of that, if we were to look at this point here, A, notice what we have here at A. At A, there is no more false negatives. And because there is no false negatives, negative would be on this side of the line. Okay, so negative. There are no diseased or robbers of the car, if you will, that are showing up on this line because we've moved it so far to this side. So this is the most sensitive setting that we could set it to. So imagine that. Imagine this in terms of our car. If we turn the sensitivity of the car alarm up very, very high, we're going to catch every single thief that's going to try to steal our car, which is represented by this curve. But we're also going to catch a lot of false positives here, which represent motorcycles and very loud cars or loudspeakers that are driving by. On the converse, if we set a very specific test at right here, notice here that we're no longer going to pick up, it'll be negative now because negative is to the left of the line. All of these things that could make the car alarm go off will be treated appropriately as a true negative. But we've made it so specific now for the car alarm to go off that there's things that thieves can do to break into your car. Okay? So long as you set this up with the negative disease on the left and the positive disease on the right, always remember that this direction is the most sensitive and this direction is the most specific, which actually is going to help us later to remember that sensitivity is on the left and specificity is on the right. Now I hope this clears things up in terms of sensitivity and specificity. The next lecture is going to talk about the actual mathematics. In this lecture I want to talk about concepts. Let's talk next about the actual mathematics and how to calculate things so you can calculate things quickly on test exams. Thanks for joining us.